This video is going to be on section 1.5 notes, quadratic equations. So a quadratic equation is an equation in the form ax squared plus bx plus c equals 0. This is important to note because you can only solve quadratic equations if you have made them equal 0 before you've gotten started. So first, I want to look at the graphical representations to see how many solutions there could be based on what the graph looks like. So once the quadratic equation equals 0, if you just graph this portion of the equation, then it will look like one of these three pictures. Somehow it could be flipped upside down or moved to the left or whatever, but it will look like this. So if you have a quadratic equation where the parabola crosses the graph like this, then there are two solutions, and we'll say they're going to be real. And you'll understand more what I mean by that later on in the notes. So two real solutions. Here you might have a quadratic where the vertex of the quadratic is sitting on the x-axis, or it could be coming up from underneath. It's just touching the x-axis. That is one real solution. And then here we have a quadratic, a parabola, where the curve is not touching the x-axis at all. So this is 0 real solutions. But there are two imaginary complex solutions. And I'll mention it when we get there, but the imaginary and complex solutions, those come from square rooting a negative number to get the solution. All right, so the first type of quadratic equation that we're going to solve are those that can be solved by factoring. So if we look at this equation, it says 2x squared minus 2x minus 24 equals 0. And when I look at this equation, I can see that each of these has a factor of 2 that I could pull out. And when you're solving an equation, you could factor it out like a GCF, if that sounds familiar. Or, since we're going to solve for x, we could just take the whole thing and divide by 2. You can't do that if what the equation has in common is a variable, but you can do that if what the equation has in common for each term is a number. All right, so I divided by 2, divided by 2, divided by 2, and I got x squared minus x minus 12 equals 0. So now the way that I factor this is I look for two numbers that will multiply to be negative 12 and add to be this number right here, and since there's no number written, it's a 1. So, and I write my work like this. You don't have to, but this is just a way I organize it. So multiply to negative 12, add to negative 1. And I'm going to show you this step on the calculator. Some of you already know what the answer is, I'm sure, but for those of us who might have a hard time with multiplication, I want to show you guys how you could use your calculator to solve this. So if you go to the y equals screen on your calculator, you can type the number that you're trying to multiply to be. I'm trying to look for numbers that multiply to negative 12. So I'm going to type negative 12, and then I'm going to type divided by x, and the x key is right here. And then there's up here above the graph key, it's in blue, it says table, so I'm going to hit the blue button to look at the table, and the table has all the pairs of numbers that multiply to negative 12. So I'm going to look for the pair of numbers that multiplies to negative 12, yes, all of them do, but adds to negative 1. So the first one adds to negative 11, adds to negative 4, and then this one adds to negative 1. And so that's the combination of numbers we're going to use, 3 and negative 4. So my factors are x plus 3, x minus 4, And then we just know that the opposite of these two factors are the solutions. X equals -3, x equals +4. All right, the next one looks like it's already in factored form. X minus 4, x plus 3. The problem is that it equals 8, and it has to equal 0. So for this problem, we're going to have to multiply these two parentheses out. So I've got x times x, x times 3, -4 times x, -4 times 3, and then I have to make it equal 0 before I can even start factoring. So I'm going to take the positive 8, and I'm going to subtract it over here, so it will be a -8 over here. So for this problem, I'm looking for two numbers that multiply to -20 but add to -1. So if I use this method again, I would do -20 divided by x, and then I would look at the table and I would look for the combination that adds to -1. And that combination is 4 and -5. 4 and -5 add to -1. So my factors are x plus 4 and x minus 5. Now the solutions are the opposite signs of those. So x equals -4, x equals +5. All right, for the next problem, anytime we are factoring, we do not want to have a negative in front of the x squared term. It just makes the factoring more complicated. So this equals 0, which is what we want, but it has a negative in the front, which I don't want. I can see a 2 right here, but that 2 is not in common for all three terms. It's just the 2 and the 8. So because this is a 15, I can't divide by 2. But I am going to divide the negative out, so at least I won't have that complicating things. Now for these problems, when you're factoring these and they have a number in the front, they're a little bit more complicated, and your teacher from whatever years you've learned how to factor before have probably taught you different methods for doing this. And the method that I find that students like the most is slide, divide, bottoms up, and so that's what I'm going to teach you. So the first step is to slide. You take the first number and you slide it over to the last number and you multiply them. So we're looking for two numbers that multiply to -16, because 2 times -8 is -16. And they need to add to 15. So -16 divided by x. So they need to add to +15. This first option adds to -16. So it's the opposite of that. 16 and -1, that's what adds to +15. 16, -1, okay. So x plus 16, x minus 1. Okay, so the first step was slide. We already did that. The second step is divide. Whatever number you slid to multiply, you now divide by that number. I slid a 2 and I multiplied by a 2, so now I'm going to divide by a 2. And then you have to simplify these fractions. They might simplify to be a reduced fraction, or they might become a whole number. So this is x plus 8. This fraction stays the same. Okay? And then the last step is you do bottoms up. Whatever the bottom, if maybe they both had fractions, you would take the denominator of the fraction and move it up to the front. So x plus 8, 2x minus 1. So that is the factored form. And now we can go ahead and say what the answers are. So this answer is -8. And this answer is +1 divided by 2. Now you can see the positive 1 over 2 up here if you look just one step back. So 1/2. All right, let's try the next one. This one currently equals 4. It should equal 0. So I'm going to subtract the 4 over 3x squared plus 4x minus 4. And then I'm going to go ahead and do slide, divide, bottoms up. So slide the 3 over to the 4. 3 times -4 is -12. So I'm looking for two numbers that multiply to -12 but add to +4. All right, so we want to add to +4. 1 and -12, 2 and -6, these are adding to negatives. So anytime that's happening, you can always just go the opposite direction. So this adds to +11, and there's the +4 right there. So -2 and 6 add to a +4. Okay, so I've got x minus 2, x plus 6. Now remember, I slid a 3 to multiply it, so now I'm going to divide by 3. The number that you slide is the number that you divide. I'm going to simplify the fractions. -2/3 can't simplify. However, 6 divided by 3 can. That's just 2. And then whatever is still a fraction, I'm going to do bottoms up. So this is 3x minus 2. And then I can go ahead and write my solutions. So this is +2 divided by 3. Which you can see up here, +2/3. And the second solution is -2. Okay, I wanted to show you guys another step in here, one way that you can check your answers on these calculators to make sure that your answer is right. And this is something we will do especially with more complicated problems. So I have 2/3. You can type it like a fraction, but 2 divided by 3 is also 2/3. I'm going to take 2/3 and I'm going to store it in the calculator. So I'm going to hit this STO button. I'm going to store it, and I'm going to store it as x. So this was one of my solutions. I'm taking the 2/3, storing it as x, and now anytime I type x, it's going to spit out 2/3 as an answer. And what I want to do is I want to make sure that if I go back to the original problem, 3x squared plus 4x, that when I plug in 2/3, it gives me 4. So 3x squared plus 4x, and each time I'm typing in the x, it's giving me 2/3. It's typing in 2/3 for me. That gives me 4. So that means that I got the right answer. Next, I'm going to do -2 stored as x. So I typed -2, and then I stored it as x. And then I'm going to go back up here, and I'm just going to grab this. So it's highlighted on the equation, and I'm going to press enter, which basically does like a copy paste. And press enter again, and this time it plugged in -2. And you'll notice that both times I got 4, which means I got the answer right. So that's a good way to check your work. That's not too painful to plug in. Okay, next we're going to solve quadratic equations by taking square roots. So here we want to get the x squared by itself and be able to square root it. And so what we need to do first is divide by 5. So x squared equals 320 divided by 5 is 64. And then when you have x squared equals 64, of course, you're going to square root it to get rid of the squared. And you have to be careful because the square root of 64 is +8, but it's also -8. So whenever you square root to solve a problem, you have to make sure that you get the positive version and the negative version. And you can write it kind of shorthand like that, or you can write x equals 8, x equals negative 8. Okay, over here, just like I said before, if you have a negative in the front, we like to kind of get rid of those. When it equals 0, we don't like to have a leading coefficient like that that's negative. So I'm going to divide by negative 1. I've got x squared plus 9 equals 0. And this problem equals 0. The last problem did not. And you'll notice I wasn't really worried about the equation equaling 0, and that's because I knew I was going to solve by taking a square root. And you can solve by taking square roots if you have an x squared term, but no plain x term. This problem's it's an exception to the rule. But if you have an x squared term and no x term, then you can do solving by taking square roots, and it doesn't really matter if the equation equals 0 or not. Okay, so let's continue this one. I'll subtract the 9 over to the other side. X squared equals negative 9. And then we're going to get the x alone by taking the square root. So x equals plus or minus. And here we have a square root of a negative number, and you can't technically square root a negative number. And so anytime that happens, I always take the negative, I make it positive, and I stick an I in the front. This is going to be an imaginary solution. So if I was to graph that quadratic, what I would find is that it would not cross the x-axis. I'm able to solve it mathematically, but it's not going to show up any x-intercepts. And then the square root of 9 is 3. So 3i. Positive 3i, negative 3i. Those are the two solutions. They're imaginary roots or imaginary x-intercepts. They don't actually show up. All right. For the next one, here they have parentheses in this problem, so we're going to kind of work from the outside in. So the first thing we can do here is we can square root. And so I end up with 2x minus 1, and then the square root of 12, I'm going to say plus minus the square root of 12. That is not a perfect square, and so I'm going to leave it like that, kind of, but it's best if I simplify radicals whenever I see them. So square root of 12, I'll do a factor tree. 12 is 6 times 2. 6 is 3 times 2. So this is a pair of 2's and a leftover 3. So a pair of 2's and a leftover 3. So root 12 and 2 root 3 are the same thing. Okay, now I can go ahead and continue solving this. So to get the x alone, I'll just add the 1 over to the other side. And typically when people write this, they don't stick the 1. You can't add the 1 to this because this is an irrational number. It's got a radical in it. The 1 is a rational number. It does not have a radical in it. So these are not like terms you can combine. Most mathematicians would probably put the 1 in the front and then plus or minus 2 root 3. And that's just because it looks similar to the quadratic formula. So we're kind of used to seeing it written that way. And then we're going to get the x alone by dividing by 2. And so x equals 1 plus 2 root 3 divided by 2. Sorry, plus or minus. You have two versions, 1 plus 2 root 3 divided by 2, 1 minus 2 root 3 divided by 2. So this would be considered the exact answer. It's the exact answer because I didn't round it all when I wrote it down, like that's the perfect answer. If I wanted to know the approximate answer, then I would type this in as a fraction. And to get a fraction on your calculator, you can hit alpha and then y equals and do the first option. and we've got 1 plus 2. The square root you do, it's right above in blue, so we're going to hit the blue button, and then this button, square root, 2 root 3 divided by 2. So there's our first approximate answer. And then for the second one, I'm going to copy paste this and go back and change it to a minus. So the two approximate answers would be 2.232 and negative 1.232. And whenever I write them, I put a squiggly equal sign so that whoever's reading my paper knows that I mean that it's approximate, it's a rounded number, where I wrote down some of the decimals, but I cut some of them off. Okay, for the next one, this one's ready to solve by taking square roots. It equals 0, which is fine. There's no negative in the front. So I'm going to go ahead and just add the 1 to the other side. And then to get the x squared alone on that side, I'll divide by 2. And then I can square root. And when you square root a fraction, you end up getting the square root of the number on the top and the square root of the number on the bottom. So this is square root 1 over square root 2. The square root of 1 is just 1. So that's 1 over square root 2. And if you recall, you're not technically supposed to leave a square root on the bottom. So I would multiply this by root 2 over root 2. That's called rationalizing the denominator. 1 times root 2 is just root 2. Anything times 1 is still itself. Root 2 times root 2, you can think of the radicals as canceling out and you just get a 2. Or you could say root 2 times root 2 is root 4, and the square root of 4 is 2. So either way, this is the number you end up with. And so you get x equals plus or minus root 2 over 2. I am not particularly picky about, I'd be okay with this answer 1 over root 2 and root 2 over 2, but I'm guessing my math lab is probably going to want the rationalized version. So just to make sure you guys are kind of aware of that. All right. The next type of quadratic equation could be solved by completing the square. So typically you would use this process on problems that have an x squared term, they have an x term. So you'll notice this is different than the last set. And these are probably problems that you couldn't factor. If you tried to factor them, it didn't work. That's how you might know that you could do completing the square. You might also be thinking, well, what about the quadratic formula? And the answer is yes, you could use the quadratic formula on these as well. So typically I wouldn't use completing the square as my method unless somebody told me that I had to. Okay, so your first step in completing the square is actually to take the number that doesn't have an x attached to it and move it over. So this first example is ready to go. And then I'm going to rewrite the problem. So it's x squared and then the x term, and then I'm going to leave a blank there. So now I'm going to take the b value. Sorry, I just got a phone call. Now I'm going to take this b value and I'm going to divide it by 2. And then I'm going to square it. So this number, 16, is the number that completes the square. So I'll use 16 to fill in the blank, and then whatever I added to the left side of the equation, I need to add to the right side of the equation as well. So now I've got parentheses squared equals whatever number ends up over here. 16 and negative 15 is 1. And then over here what I have is x and whatever number I got when I divided by 2. And that was a negative 4. So I'm going to write minus 4. So I have x minus 4 squared equals 1. And at this point, this is really similar to this equation right here. And that's kind of how you finish the process. So now we're going to solve for that x. We're going to square root both sides. I'm going to put my work up here. I get x minus 4 equals plus or minus the square root of 1. The square root of 1 is just 1, so plus or minus 1. And then I have x minus 4, so I'll just go ahead and add the 4 over. So I have positive 1 plus 4, which is 5. And I have negative 1 plus 4, which is 3. So this particular problem you might look at, you could have factored this one if you wanted, but completing the square would also work. All right. This example, we have negatives for each term, so I'm going to go ahead and divide by negative 1 before I even get started. And then I would prefer for this number to be moved over so I can leave my blank space. All right, so I'm going to take this term, divide it by 2, and square it. So 6 divided by 2 is 3, 3 squared is 9, so 9 is the number that completes the square. If I've added 9 to the left side of the equation, then I should add 9 to the right side of the equation as well. And so my answer is something squared equals 9 minus 7 is 2. In the parentheses, I'm going to have an x, and then whatever number I got when I divided by 2, which is a positive 3. All right. From here, I can go ahead and start solving for x. So I'm going to square root each side. I get x plus 3 equals plus or minus the square root of 2. And then to get the x alone, I'll just subtract the 3 over to the other side. And this is the exact answer. If I wanted the approximate answer, I could type this in on my calculator. So it would be negative 3 plus square root 2, negative 3 minus square root 2 would be the two approximate answers. All right, let's look at the next one. Now this one, the easiest way to do this problem would be to say, okay, there's a 4 in front of the x squared, so I can just divide each of these terms by 4. And since this is an equation, you can do that. I am not going to show you that method because later on in this course, we're going to run into completing the square problems again. We're going to run into problems that have a number in the front, and we are not going to be able to do that. So I want to teach you consistently. I don't want to teach you two different methods for a similar type of problem. So I'm going to teach you how to do this leaving the number in there. But if this feels too complicated, just divide this whole thing by 4 and do it like these first two examples, okay? Because it'll work. All right, so if you have a number in the front and you're completing a square, you're going to start off by taking the number in the front out, but leaving it sitting right there. And notice this equation was already ready to go for that completing the square method because the plain number was already on the right side. So I have x squared minus 8x plus blank. And the reason I have 8x is because 32 divided by 4 gives you 8. All right, so now I'm going to go through the process. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16. So the number that completes the square is 16. And I know that whatever I added to the left side, I have to add to the right side as well. But I didn't technically add 16 to the left side. I added 4 times 16 because I got 4 in the parentheses. 4 times 16. So I actually added 64 to the left side, which means I need to add 64 to the right side. That's the part that makes the number in the front just a little bit more complicated. So now I've still got the 4 in the front, and then I got my parentheses, and then I have a number on the right. negative 44, and positive 64 is 20. And then inside the parentheses, I have my x and negative 4. So now I can go through the process of solving. I'm going to kind of work from the outside in. So the squared is there, and I will want to square root, but before I do that, I need to get rid of this coefficient of 4. So I'm going to divide the whole thing by 4. And then I get x minus 4 squared equals 5. And then I can square root each side. X minus 4 equals plus or minus square root 5. And then I can take this 4, I can just add a 4 to the other side. So this is my exact answer, and if I wanted the approximate answer, I could plug in both options, one with a plus, one with a minus. All right, let's try that again. So first thing, I'm going to take this number and move it over to the other side. I have a number in the front, so I'm going to factor that out. 3 doesn't divide by 2 evenly, so I'm just going to write 3/2. And depending on whatever you're comfortable with, you can write this as fraction or decimals. Both of them are fine. They're both accurate. All right, so now I'm going to take this middle term. I'm going to divide it by 2. Negative 3/2 divided in half is negative 3/4. So what happens is this 2 doubled the denominator. Negative 3/2 divided by 2 is negative 3/4. Now I'm going to take that and I'm going to square it. And I get negative 3 squared is 9, 4 squared is 16. So 9 over 16 is the number that completes the square. But I didn't really add 9 over 16 to the left side. I really added 2 times 9 over 16. And if this is getting a little bit too much with the fractions for you, you can do 2 times 9 divided by 16. It'll give you the decimal. You can use the decimal if you're more comfortable with that, or I'm going to go ahead and stick with fractions. Let me show you what I typed in. I hit the math button. That turns it into a fraction for me. If I use option number 1, the fraction is 9/8. Okay, so my number in front of the parentheses is 2. And then I have 9/8, and I'm going to add 4 to that. Plus 4. 41/8. Okay. In the parentheses, I have an x. When I divided by 2, I got negative 3/4. Okay, so I can go about solving this. The first thing I'm going to do is divide by 2. So I have x minus 3/4 squared. 41 over 8 divided by 2 is 41 over 16. So whatever was in the denominator is going to get doubled. It's divided in half, which means it doubles the denominator. All right, now I need to square root both sides. X minus 3/4 is plus or minus the square root of 41 over 16, which is square root 41 over square root 16. 41 is not a perfect square, so when you square root it, it's still going to stay 41, but 16 is a perfect square. When you square root that, you're just going to get 4. So I'm going to take this negative 3/4, I'm going to add it over to the other side, 3/4, plus or minus, square root of 41 on the top, 4 on the bottom. And you can kind of mush those together. You can write this as 3 plus square root 41 over a denominator of 4. You can write it as one piece, but writing it this way is fine too. All right, and that's the exact answer. We could type those in if we wanted to know the approximate answers. All right, and then last, the quadratic formula. So the quadratic formula says if you have ax squared plus bx plus c equals 0, this one you for sure have to equal 0. Then using just the numbers in front of the x terms and the plain number on the end, you can plug them into this formula. I also put this down here. This has to do with the discriminant. The discriminant specifically is the numbers that make up the inside of the square root. When you have 0 real solutions, that means you have 2 imaginary solutions. So it doesn't mean you have no answers. It just means that the answers that you have are going to have i's in them. Okay, so let's go ahead and practice this. This one is ready to go. It equals 0 already. So we're going to say x equals negative b, so negative 8 plus or minus b squared minus 4 times the a value. If that's the number in front of x squared, that's just a 1. 4 times a times c, the c value is 6, all divided by 2 times a. So when I simplify these, 2 times 1 is 2. I write the whole thing out like that. And then I write it like this because what I really need to just do is figure out the discriminant. And it could be negative, so I'm not going to put the square root over it because my calculator will not like square rooting a negative. So I'm typing in 8 squared minus 4 times 1 times 6. If you need the squared button, it's right here. So 8 squared minus 4 times 1 times 6 is 40. So I have negative 8 plus or minus the square root of 40. Off to the side, I'm going to go ahead and do a factor tree on 40. That's 4 times 10. 4 is 2 times 2. 10 is 5 times 2. So we have a pair of 2s, a leftover 5, a leftover 2. Okay, so a pair of 2s, and then a leftover 5 and a leftover 2. 5 times 2 is 10. So 2 root 10 is the same thing as root 40. Okay, now when you have an answer that looks like this, you can reduce these numbers if they all have the same number in common. So here, 8, 2, and 2, I can divide all of those by 2. 2 divided by 2. I wrote down that I was dividing by 2. I'm sorry, guys. That was a silly mistake. Okay. 8 divided by 2 is 4. 2 divided by 2 is 1. 2 divided by 2 is 1. Okay. So the final answer here would be negative 4 plus or minus. This is a 1 root 10, but most people will just write root 10. So negative 4 plus or minus root 10. And then the whole thing is written over a 1, which you wouldn't even write. So that's the final answer. All right, so x equals negative b. Now if the b value is negative 6, the negative b is the negative version of negative 6. So the negative version of negative 6. And what you'll notice is I have 2 negatives in a row, which means that it's just positive. I've got positive 6. And then b squared minus 4 times a times c, all divided by 2 times a. And then, like I said, I put this number and I put this number, and then I leave this blank because I'm going to use my calculator. Now, be really careful when you're squaring your negatives. They have to be in parentheses when you square them. So negative 6 squared minus 4 times 1 times 11. negative 8. I've got a negative under the square root, so I'm going to make that positive, and I'm just going to stick an I in the front. I know that my answer is imaginary. So if I was to graph this, this quadratic, this parabola, does not cross the x-axis. Okay, let me simplify my square root of 8 off to the side. 8 is 2 times 4. 4 is 2 times 2. So I have a pair of 2's and a leftover 2. So 8 I'm going to rewrite as 2 root 2. And I have the I, so I'm going to stick the I in there. And then just like the last problem, if we can divide the same number out of all of these, we're going to do that. And we can divide a 2 out. So 6 divided by 2 is 3, 2 divided by 2 is 1, 2 divided by 2 is 1. So the solution here is 3 plus or minus I root 2. All right, this one needs to equal 0 before we get started, so I'm going to subtract this over 4x squared minus 12x plus 9 equals 0. So the negative version of b plus or minus b squared minus 4 times a times c, all divided by 2 times a. So that makes positive 12. And I need to type in negative 12 squared minus 4 times 9. That's 0. This discriminant is 0, so the square root is just not even going to matter in this problem. This just gives me 12 over 8. Both of those are divisible by 4. So 12 divided by 4 is 3, 8 divided by 4 is 2. So this is 3 over 2. This is one of those situations where your parabola is just sitting on the x-axis at one point, at the vertex. All right, last problem. So we have x equals negative b. So my b value was negative, so I did the negative version of the b value, plus or minus b squared minus 4 times a times c, all divided by 2a. Okay, so we'll type in the discriminant. $25. So this one's unique because that's a perfect square. This problem would have been factorable if we wanted to do it that way. Square root of 25 is 5. So we have 3 plus 5, which is 8. Divided by 4. 8 divided by 4 is 2. 3 minus 5 is negative 2. Negative 2 divided by 4 is negative 1/2. So this problem, if we had done it by factoring, we could have. Okay, so here's some strategy down here because we just learned, well, reviewed really, a lot of different ways. So factoring, taking square roots, completing the square, and the quadratic formula. Let's make sure that we know when to use what. So if b equals 0, that means that you only have the x squared term and the number. Then take square roots. Okay? If ax squared plus bx plus c can be easily factored, that's the next easiest thing to do. is to solve it by factoring. If the equation cannot be solved by the square root property or factoring, then use the quadratic formula. And technically, it could be the quadratic formula or completing the square because they would both work. Quadratic formula and completing the square work on any equation ever. Even if the b value is 0, you could just plug 0 in for b. They will always work, okay? This strategy is just telling you what to do, what's the most easy procedure to like what procedures you would probably want to avoid. All right. To check your answers, you can graph them and then make sure the x-intercepts are what you're seeing, or you can do what I showed you before and type them in on your calculator and plug them into the equation and just make sure that they're right. Okay. We're not done yet. We have a couple application problems. These are real world problems. So first example says, in tennis, a lob can be used to buy time to get into position. The approximate height s in feet for a tennis ball that is hit straight upward at v sub 0 feet per second from a height of s sub 0 feet is modeled by s equals negative 16t squared plus v sub 0 t plus s sub 0, where t is the time in seconds. So first they want you to use the graph to estimate the time. So here is where the person hit the lob, the tennis ball goes up in the air and then it comes back down, and this is where it hits the ground. So if I'm going to make an estimate on the time it was in the air, I'd say like a little less than 4 seconds. So maybe like 3.8 to 3.9 seconds. Somewhere around there is going to be my estimate. And then it says, it gave you some specific information, which we didn't need because we had the graph, but it says if you have a velocity of 60 feet, straight upward, 60 feet per second, that's going to be this value is 60 feet per second. So we're going to put 60 in here. From a height of 5 feet. So we're going to put a 5 in here. So they're telling you to work with the equation y equals negative 16t squared plus 60t plus 5. Okay, so they said here to approximate the time by using the quadratic formula. Go ahead and pause the video and see if you can get the correct answer by using the quadratic formula. Pause the video, work at the problem out, and then unpause and check your work. All right, so t equals negative b plus or minus square root of b squared minus 4 times a times c divided by 2a. So there's your discriminant. And then we have to type this in. So alpha y equals negative 60 plus the square root 3,920 divided by negative 32. A negative time is not an answer that's going to work. That's actually this answer over here if this was to be graphed. You can see that a negative very small decimal is your first time, so it makes sense that we found it. It just is not the answer for the problem. So I'm going to ignore that answer. I'm going to copy paste this, change the plus to a minus, 3.832 seconds. To avoid hitting the ball out, a tennis player in one corner of the 312-yard squared court hits the ball to the farthest corner of the opponent's side as shown in the diagram. If the length L of the tennis court is 2 yards longer than twice the width W, then how far did the player hit the ball? So the length and the width, we know length times width is 312. The length is 2 yards longer than twice the width. So 2 times the width, twice the width, and 2 yards longer than that. The width is just the width. Okay, so I'm going to say length times width equals the overall area. Length times width equals the overall area. And I'll go ahead, when I look at this, before I start doing work without explaining what I'm doing, length times width equals area. Right now this is in factored form, but it's not going to help me solve anything because it equals 312, not 0. So I'm going to go ahead and multiply this. 2w squared plus 2w equals 312. I'm going to make it equal 0. And when I look at these numbers, I notice that I can divide all of them by 2. So I'll go ahead and do that. I'll make the problem easier. So I'm going to see if we can factor this because that's easier than the quadratic formula and stuff. So I'm looking for a number that multiplies to negative 156 but adds to positive 1. So that's negative 155, negative 76, negative 49. So we're getting closer. Negative 20. Notice I'm ignoring all the ones that have decimals because those are definitely not it. Positive 12, negative 13 adds to negative 1. We want positive 1. There we go. Positive 13, negative 12. So we have w plus 13, w minus 12. So we have 2 solutions for w. W could be negative 13, W could be positive 12. The width of the court is not going to be a negative number. Okay, so the width of the court is 12. The length of the court is 2 times 12 plus 2. 2 times 12 is 24. 24 plus 2 is 26. Okay, so what we have going on now is we need to find this diagonal. And that diagonal is going to come from a right triangle. And if you guys recall, the Pythagorean theorem can help you find the diagonal of a right triangle. So I'm going to say 12 squared plus 26 squared equals the distance that the tennis ball traveled from one corner of the court to the other corner of the court. 12 squared plus 26 squared, 820 is, excuse me, I missed the squared here, equals the distance squared. A squared plus b squared equals c squared. And so now I need to square root and we know with square roots we always take the positive and the negative answer, but a negative distance doesn't make sense. So I'm just going to use the positive version. So the distance between one corner of the court and the other, where that tennis ball was hit, is a distance of 28.636 yards. Whew, and there we go.